Good evening. Thanks everybody for coming out to LSPE. Tonight we're going to be talking about logging, and what we've got is we've got three customers of three very different logging solutions coming tonight. We're going to lead off with Peter Ellehauge from Yahoo, who's using Splunk. After that, we're going to have Karl Armani talking about how he uses SumoLogic, and we'll close up with Tin Lei from LinkedIn talking about how they use the ELK stack. So without further ado, take it away, Peter.
Oh. This is what? Special thing?
There it is. Okay.
Cool. Yeah, thanks to Ian. My name is Peter Ellehauge. I'm from Yahoo. I have done a little LS of what I want to cover here today, focusing on Splunk. First, who am I? I'm what we at Yahoo call a double boomerang. So I join Yahoo and then I leave, and then I join and then I leave, and then I join. So I think the first time I joined Yahoo was in '99. The second time was in 2000 and something. I think that was before DevOps was a thing. I joined over in search operations team.
You're having a little trouble hearing you in the back. Can you put the mic a little closer?
Better now? I guess that means you can hear me. Good. I'm also, I guess, what you call a security practitioner. I have 5 to 6 years of Splunk under my belt, about 3 years at Groupon, and 2.5 years here at Yahoo. Alan Turing, he's one of my personal heroes, and I was very happy when I noticed that I can run a marathon faster than he could. So, I don't know. I don't know. Is it safe to assume that everybody here knows what Splunk is? Maybe not. So, it indexes data in real time. It's a very strong query language with a lot of statistics function and a very strong presentation and visualization interface. Normally, and if there are any people from Splunk here, then it's probably now a good time to look away. So my internal little crude mental picture of what Splunk is distributed grape you pipe into salt, and then you have a new flood at the end. At Yahoo, we have a very high variety of Splunk infrastructure. We have a lot of clusters with one server. It's indexer and search heads, but we also have several clusters where we have hundreds of indexes. We have up to thousands of forwarders. A forwarder in Splunk language is a log-producing server. We have all sorts of different source types. So in Splunk there's a monitored input, which means it's basically a tailback F on the log file, and then it's forwarded into an index on the indexer. There's what's called scripted input. That's some script that's run on a server, and then that's producing the output that's being indexed. You're also using syslog in some instances to forward the data directly into the indexers. And then a little bit more specific to Yahoo, we have built or using some of the Splunk facilities, so we can integrate with the Yahoo single sign-on, and that's where we are managing all the users and how they are assigned to the different roles in Splunk. The team I'm currently part of, Yahoo Search, we are in the middle of standing up what I would guess is a standard Splunk use case. We have an awful lot of servers that are producing web server logs. We want to index that into Splunk and allow that we can do traffic trending. We can do latency and error rates and all these other good things that you normally do with a Splunk instance. Developers will use it to do debugging and go and see, where is this error occurring and how often is it occurring. We can also use this to monitor our service when the infrastructure changes around it. Maybe there will be new load balancer or how the traffic is routed inside the data center, then we can keep track of that. And another really, really strong use case here is test buckets. We have a lot of test buckets, so we will have a very high dimensions of all of these mentioned metrics. And for this cluster, we expect to have about 100 and some indexes in several different data centers around the world. And by the way, if there are any questions, then please. I have also, as I mentioned, I'm a security practitioner, so I've been part of the security team where we have a lot of security scanners that's producing a lot of differently formatted output. We have both some third-party scanners, but we also have some proprietary. For some of these third-party scanners, there was a lot of Splunk applications available out there, so we could immediately get some dashboards and charts and all this good stuff. However, it didn't really work at our scale because my team was scanning several hundred thousands of servers. And that's anybody that's been running a port scanner or something like Nessus, they will know that there will be a lot of informational output, and we are indexing everything. So we had to create our own application in Splunk, but that also allows us to integrate that with some of the other infrastructure pieces or some of the other services we have, like our ticketing system and so on. Similar issues we had with some of the sensor data from network devices or IDS systems and similar. Another interesting use case we had in security was our bug bounty program. When that launched, we tried to manage all these external vulnerability reports by keeping track of it in some spreadsheets. And that turned out that was pretty difficult, mostly because we had a lot of reports. We had a lot of different people trying to collaborate and figuring out, oh, I think this column should be named this and that column should be named that. And then when you created another spreadsheet, then it was another person, so the column had another name. I think we ended up having 6 different spreadsheets. So I took this task upon me to try and make sense out of all this data from these 6 different spreadsheets, because we wanted to see how the different security researchers was doing in terms of how high quality of the report can we expect. I mean, is this a researcher that every time he reports anything, it's a true vulnerability, or is it just someone that's like, oh, I think there's a cross-site scripting here, so let me just send an email to these guys. But I mean, because of all these different names of the columns and so on, it was kind of a data normalization hell. And what was even more tricky was how to ensure that the different row was correlated across these many spreadsheets. So, like a ticket number that would be correlated as or used as a foreign key in another spreadsheet. So I came up with some Splunk macros like this one, and of notice here is that this seems like a pretty complicated macro, and it's referencing 3 similarly complicated macros. That's what it took to kind of make sense out of and normalize data from 6 different spreadsheets. But we got a really nice dashboard out of it, so we can see how the bug bounty, how much bounty we are paying out over time, how the researchers are doing, and how we are doing in terms of response time to these researchers. Recently, we have had a lot of internal initiatives in CI/CD. We are keeping track of how the CI/CD pipelines are doing, and there's a lot of log output there. How many errors were there? Where is the build failing? How many of these tests are passing? How long time does it take? We also are keeping track of code reviews. And this is all data that's updated fairly frequently, and it's all data that we want to keep track of and see how are we doing in terms of code review. Is all our commits, are they being reviewed? Where in the pipeline is the problem that's preventing this build from proceeding? So initially we tried to do that in some of the teams by sharing a spreadsheet, because we only want to have the data updated once a week. So it's fine. I can just dump it into a spreadsheet and share it with everybody. And then I'll just create this standard pie chart, and you can see, ooh, this is how we're doing. It's simple. Everybody can do it. And typically it's something one person produces it and sends to everybody. And yes, sir?
Yeah, what do you mean by spreadsheet?
Excel spreadsheets, for example, or some
file.
So it's a file, yeah. So it's a file you share through email, so everybody gets this file, and then they open it in Excel or whatever it is, and then you get this data that I have shared.
Oh.
You can do very little with the data. Well, I mean, you can go and modify it, but I mean, next week there will be a new update. So whatever macro or change in a pie chart that you have made that makes it useful for you, you will have to do it again next week. Maybe then you can save the spreadsheet on a shared drive, or Dropbox or Box, or what all these tools are called, or a Google Doc. But again, you cannot go in then now you would go in and kind of change the spreadsheet for everybody, and just because you may be in networking, that doesn't mean that people over in marketing that would enjoy the changes that you have made. But it allows a little bit of a collaboration. So I put the data into Splunk for our team, and then I thought maybe I could make some sense out of the data for at least my team. And then I shared the link. So the way I did it was that I take all these CSV files, put it in as a lookup table in Splunk. I only have a single server because it's not really that much data. This is not where the scale is. The scale is at the other end because I will have hundreds, maybe even thousands of consumers of this data. And then I shared this link. And then it kind of got interesting because then we get into this, oh, Alison down in marketing, she wants this graph, and Bob over in networking, he wants this other graph. Oh, and I want my own saved query because now I have come up with this way that I want to slice and dice this data. So then I had to do the next iteration of this data, so I created a dashboard with some drop-down, so you could select, oh, okay, here's for this team or for this developer and so on. And the nice thing about that is when you create this kind of a dashboard in Splunk, then you will get a URL you can bookmark, and then that means that every time you visit that bookmark, you will get the exact same data or the freshest data that you have, because it will always reference into Splunk. So the lessons I learned, yes sir?
Okay, can I call you to the exact time?
Sure.
I mean, when you talk about the bookmarking,
Uh-huh.
it's possible to point to that time because I would like to share this thing I see right now.
Oh yeah, I mean, so in Splunk, I mean, you can provide you can select the start and end time for the data that you want to see. So if you want to share a link for the past week, then you go into what's called a time picker, and then you just select last week, and then you can share this link with everybody, and then they will go and get this. But if you share the link without this time selection, then every time people visit that link, they will always get this report with the most up-to-date data. So the lessons I learned from some of this was that I thought, oh, okay, I can just dump this data into Splunk, and then I'll create a dashboard, and then I have solved this problem. Well, maybe I have solved a little bit of my own problem in terms of how I want to use the data. But it turned out that there is a lot of different use cases out there. So I had to go back a little bit and create some flexibility around that would allow 90% of the users to get the view of the data that they wanted. But the nice thing was that by doing this, everybody had always access to the same data, and it was always up to date. And it also created a lot of creativity by the users, because then they came up with some queries that I've never thought about that could be useful in order to keep track of that project. And yes?
As far as I remember, Splunk storing the data for 90 days, right? Or I'm wrong.
No, so the question is if that Splunk stores the data for 90 days. That is something you can configure in your Splunk instance, and of course it also depends on how much disk you have available. But in this case, actually, for my use case, disk space was not an issue, because I think the data is, for most of these projects I mentioned here, apart from the Yahoo search web server logs, the data is maybe less than 10 gigs. And it all fits on a single server. The scale comes to that I've given everybody access to kind of collaborate on top and use this data in a very easy way. So, in conclusion, I think in the future, I'm going to index all the data I can get my hands on, whether or not it's being updated frequently, because I think I learned that there is always something that you can find in this data. And another thing is that you should not restrict access to only the people you think will find this data useful, because there may be other teams that can make use out of that data. And then, of course, as always, you should listen to your users and create what helps them be successful in their job. Yes?
So am I correct that it's somehow connected to the Yahoo sign-on, so managing rules and so on?
Yeah.
So in that you can specify that executives who act and access that dashboard.
Yeah. So the question was the integration with the Yahoo single sign-on, how to manage the users and the roles and who has access to the data. So yes, that is possible to do with this single sign-on system. But in most of the cases, I've actually chosen to create what's called a default role, which is that everybody would have at least read access to the data, so they can go in and do their own queries in there. And I'll also give them access to actually create their own queries, although in some cases that's a little bit dangerous, because if you are using too many wildcards, then you may be able to bring the cluster down, but the cluster is only one server and there's not a lot of data, so chances that you will overload the server is very slim. Yes?
Did I hear correctly earlier that you mentioned the aggregate data is 10 gig?
Yeah, it's less than 10 gig.
Can you give some context to it when you're talking about tens of hundreds of or thousands of servers and only 10 gig of data? Is that aggregate numbers only, or is it provided? Can you give us some context?
Okay, yeah. So the question is what does this 10 gig of data refer to? So the 10 gig of data was to most of this data that was coming out of spreadsheets or the CI/CD pipeline. the hundreds of indexes and the thousands of forwarders, that's of course a completely different scale. I haven't built that cluster yet, so I cannot tell you exactly how much data it is. But it's probably going to be in the hundreds of gigabytes per day. Yes?
So when you say don't restrict access to data, is there an assumption that people who have access to, let's say, the presentation of this data really have the ability to look at the same, there's an assumption that this data is classified all the same from a sensitivity perspective, right? So if you're dealing with certain vulnerabilities or bugs, and one happens to be, let's say, with a part of a financial system that you guys are taking payments on, that to me would be treated as a different label versus something that is just general for researchers. I mean, can you explain what do you mean by that statement a little bit more in depth?
Well, I mean, so the question is around giving access, giving all users access to the data. So there, I mean, the data, even if you think that, oh, this data you are currently sitting and working with, it's not sensitive, but yeah, it's only this team that needs access. So I'm only talking about obviously about the non-sensitive data, so not anything financial or any sensitive box and so on. But I mean, so this CI/CD and some of the other corporate initiatives where it's by default is that something that affects everybody in the organization, then let everybody have access, even people over in marketing or wherever, which you may not assume that they cannot have any use for the data. You will be surprised.
Okay.
Any other questions? If you have any other questions, you can find me at these two addresses. Okay, thank you.
Thanks a lot, Peter. A couple quick notes while we change speakers. Tonight, for the first time, we're actually recording this. So there's a recorder somewhere in the sky getting all of this recorded. We'll put it up on the site afterwards. So you'll be able to look at this, share it with your friends. Also, in the back of the room, we have Sam Kotwan from Splunk. Sam, can you raise your hand? So he can answer any questions you have about Splunk as well. So next up, we have Karl Armani here from Medallia. He's going to be talking about how they use SumoLogic.
Hi, Karl Armani. I'm the Senior Director of Infrastructure and Operations at Medallia. Just by a show of hands, to get some context, how many folks have heard of Medallia before? All right, a good number of people. So I'm going to just give a 2-minute introduction about what Medallia does, just because there's a parallel to how we thought about SumoLogic and how we implemented SumoLogic. So Medallia is a customer experience management system, or CEM, and essentially what we do, sorry for the color here, we enable companies to efficiently capture, analyze, and act on customer feedback. And the way that we do that is by essentially capturing feedback from multiple channels, whether it's via surveys, mobile, social media, call centers, various different sources, allow companies at various levels from the front line all the way to the CEO to interact with the data, analyze it, report on it, and get insight from that so that they can act and improve the customer experience. The platform that enables this is a data engine that is custom developed at Medallia. It's an in-memory analytics engine with native analytics and organizational mapping capabilities specific to the platform or the CEM platform that we're in the business for. All right. The other thing is that we are a SaaS company. So when we thought about how do we manage our environment, our platform, we're a SaaS company, so we run the platform that we sell, that we provide to our customers. We want to make sure that it's running with top quality, good performance, all of these capabilities. We want to monitor it and be able to know that we are running a good environment and have a good handle on that. So when we thought about that, we thought the same thing that we do for our customers, we want a solution that does the same thing, which means we wanted to be able to capture good data and metrics from various sources within our environment, the infrastructure, the application layer, the network layer. We wanted to be able to search for patterns within that data. We want to be able to analyze it, understand what the performance, what the quality levels are, and be able to do correlations and predict based on certain trends and metrics. And so that we can act on that, meaning prevent failures, how to improve quality, make sure that the environment is running in a healthy and a good state. So in addition, just like we think about Medallia, we want to prefer a SaaS solution. We believe in the SaaS model. So, and we have a small team, company that's growing really, really fast. We prefer to kind of focus on the core business, and we want, if we find a SaaS solution that can give us all of that, that would be a preference. And we wanted to do all of that in real time. We wanted to know exactly as things are happening that we're able to detect those in real time. So the first thing, wanted to capture good metrics, and we found out that we are already capturing a lot of very good data, except it looks like this, and it's distributed on every single server and application log in the environment. So the question was, how do we get some insight into this data. I always kind of give the example that running our environment is like running a complex airplane or an engine. And we need real-time feedback to understand how everything is going so that if anything is not going well, we're able to react to it very, very quickly. So we wanted a dashboard for our entire environment. So after looking at various solutions, we decided to go with SumoLogic. SumoLogic allowed us to be able to collect all of that good data that we had in many, many servers and application logs and bring that into a central location so that also we can do search, analyze, detect failures, and manage the environment. And just like Medallia, SumoLogic allows us to do that in real time. And it's a SaaS solution, so we don't have to worry about the infrastructure that's running this tool and all of the development and capabilities that we have to keep working on just to make the tool work. Let someone else worry about that. So some of the capabilities that I will highlight that how we use SumoLogic at Medallia is, one is, as we collect the data, obviously, just like any of the other solutions, whether it's Splunk or others, it allows us to be able to search into that data. And one of the features that we use as well is a feature called log reduce. And essentially, as SumoLogic ingests the data, it allows you to say, what are some of how do we bucketize the events that are in the data? How many events of this type and that type and that type? It allows us to look at that and say, okay, there's something that is new, that's just popped up in the logs, and I can see that quickly without having to search through the logs and say, oh, there's a new event that just started happening today, or these events that usually happen at a particular volume have decreased or increased. The other one is around detect. This is the anomaly detection feature within SumoLogic, and we define certain things that started happening, either increased, decreased, showed up new. We can show that at various levels to say, these are anomalies, and we can click into these and we can actually configure a lot more capabilities to say, what is this anomaly telling us? Is this a detection of a new event, and this event means it's a misbehavior on the application side, or if it's a security issue. The other capability is monitoring and visualizing. We started off by correlating a lot of events to understand. We provide data for our customers in real time. So it's important that as we ingest the data from the various sources that I mentioned earlier, that we bring that into the customer instance so that they can report on that and act on it in near real-time fashion. So being able to correlate the events as each data point comes into our environment and goes through various processing phases, understanding that how long it took and what are some issues. We started doing that on our own, and recently SumoLogic kind of enabled the capability of doing transaction analytics, where you say there's a transaction of 10 steps that happened within my application, how many succeeded on the first step, second step. So if there's a drop on a particular step within the transaction, you know exactly where the failure is, and they provided some better visualization for that. But one of the features that is my favorite and I like the most in terms of our decision point for SumoLogic is that as you're sending the data to SumoLogic in near real time, they have the capability to take that data into two streams. One stream that goes and gets indexed so that you can search on it and later, and one stream that goes and updates any dashboards that you have created. So this is an example of one of our dashboards where essentially the queries that we run on a regular basis, we said, I'm going to pin that into a dashboard, and this dashboard gets updated in near real time as the data is coming in. So I don't need to keep searching and searching again. So we ended up creating about probably a couple of dozen dashboards, and the teams, instead of having to search every time they want to look for a pattern, all of the searches that they do on a regular basis, they just bring up the dashboards and they can see if there's a trend, any dip, any spike, any change in the data that's coming in. One of my favorite use cases with SumoLogic is like every morning when I come into the office, I drink a double espresso, and by the time that I finish drinking a double espresso, I've already navigated through about a dozen or 15 dashboards and look at every single aspect of the environment, of the infrastructure, the application. Is there anything out of the ordinary that now our team needs to go and dive deep into and investigate? Another feature that we use pretty often is around scheduled searches. So one of the capabilities within SumoLogic is you can say, I want to run this query every 15 minutes, and if the results match this event or the number of errors is above X, then send us an email that there's this condition, so that if somebody didn't look at the dashboard, we use that to send that to our level 1 support team or not. And essentially it said there's a new condition that was detected in the logs, and you can run the search on one machine, you can run it on 100 machines, and define the condition that you want, and then get the alert and say there's some new event that has been detected in the environment, and then someone can act on that. So just to recap, these are our use cases for, with SumoLogic, and it allowed us to collect and centralize in a very quick manner. I remember when we first went into the implementation, within a few hours, we had set up the collectors and send out a few servers, about 5 servers, to the environment, and we were setting up dashboards. Within a couple of hours, we already had a few dashboards up and running with SumoLogic. It allows us to search and analyze in a lot of different ways. We detect and predict based on patterns. We have dashboards that are based on hourly metrics, on daily metrics, and we can look at that all the time. Monitoring and visualization of the data is very powerful, and the alerts and the notifications. So when we started, I always like to show this, when we started using SumoLogic, we brought in a TV on a mobile cart and put it right kind of by the team to kind of look at some of the important metrics. But then we got multiple rounds of funding, and we ended up putting a lot of TVs around the ops area, showing all the different charts and metrics that we want to be visible and highlight those kind of all the time. And that's all I have. Happy to take any questions.
Do they have any escalation later in that event? So again, that's specify that the first time that alert received, it should be sent to the base email. After that, no other changes after the 10 minutes or half an hour, it should be sent to another email. And at the end, it should be called to someone and so on. Is any?
I don't. So the question was, is there any escalation workflow in the tool that allows certain events to be escalated after a while? I don't believe there's capabilities within the tool to do escalation workflow. I mean, this is more of a log management tool. We use that. We define our searches to say this is the first search is at this threshold, and the second search is at this threshold. And then we use PagerDuty to kind of run escalations and other tools. But this is more of a log management tool. There might be some, I know we've spoken recently with the team, and they're working on defining certain workflows and capabilities specifically geared towards DevOps within the tools itself. I'm not sure whether like an escalation workflow will be included in that or not. Yes?
Did you find issues with, or I should say concerns with security, sending logs of this volume and of this scope to a third party?
Sure. So the question was, do you have any concerns or issues with security sending these logs? So one of the things that we implemented as we put the logs is you can define a lot of rules to say what you're sending. So for example, we said we log, debug level data in our application log, but that's not a lot of volume and we don't need. We can look at those. We don't want to send those. So you can put certain matches. You can say, if there's a username or a password or a number, we don't use credit card numbers, but you can say, I want to mask those before sending them to SumoLogic. You can encrypt the data that you're sending, and it gets compressed as well. So no concerns, to answer your question from our side, but there are capabilities in the tool to mask certain data and restrict certain data to say, I want to send this. If a line in the log looks like this, I want to send it. If it looks like this, I don't want to send that. Yes?
So I have a couple of questions. So first, about the team. So are you using it just in DevOps, or is it also being used by developers? Did you see any, barriers in implementing it with developers, or educating developers how to use the tool? Or
yeah. So the question was, is your team only using it, or are developers also using that? Were there any barriers in terms of adoption, right? And the answer is, we saw a little bit of barriers in the beginning because we were focused on using the tool ourselves. Once we started actually putting the TVs and the monitors and showing kind of the capabilities, we're now seeing a lot of developers using it and creating their own dashboards and their own searches that go directly to them. And I know there's quite a bit of DevOps-friendly functionality that is coming in the tool as well in terms of workflow and how the different teams can collaborate on creating a shared space that different people can pin searches and graphs into. But we're seeing a lot of adoption now on the developers, that they're seeing kind of the capability that I can get the metrics that I need and put a dashboard and it will be the metrics that I care about.
so another question: did you go through a phase of reshaping your logs, or working on the logs to make them look nicer for SumoLogic to digest?
Yes, the question is, are you reshaping your logs or working on making them friendlier? It's a work in progress. That's what I would say. And I see one of the members on our team, they're kind of smiling because it's something that we keep asking kind of the development teams and all the various teams, that kind of putting messages in the logs, to standardize as much as possible. We do capture a lot of good data, and you can structure your queries if the data is there. It doesn't need to be pretty for you to be able to write a query, but it just makes it easier sometimes if the structure is the same and the same message is logged in with the same language and the same level of details and levels of severity. So we're working on that. It definitely makes things easier when you want to structure your queries, but it hasn't been a barrier for us. Yes?
What kind of limits have you run into with the log volume size and as well as the transfer rate of being able to push logs to the service?
Yes, good question. The question is, what rate limits have you run into in terms of sending data? So currently we send about between 150 to about 250 gigs on some days. Our average is about 150 gigs. We did some tests when we started the project or the implementation. We actually ran it and measured what's the impact on the bandwidth and all of that, and it was fairly minimal. The collectors compressed the data really, really well, and I know that. So we haven't run into any limits because I know that also SumoLogic has customers that are pushing terabytes of data into their environment. So I don't think we're anywhere close to that, although we are starting to get up there, but I think we have a way to go before we need to talk about any limitations. Yes?
So what's your takeaway of monitoring and alerting on the high granularity data? So basically, you don't want, you do want to know, you do want to have insight of very, fine granularity signals, But but on the other hand, you don't want to monitor, let's say, thousands of signals, so that it's out of humans' ability to monitor and alert them.
Yes, so let me see if I understood your question. Is how do you figure out, like, you don't want to monitor everything, but you want to also get insight into what's going on into the environment, or find out the right signals that to monitor for. And that's actually an extremely important point, because the first thing when we started setting up the dashboard, it's something that we ran into. It's like, oh, I want to look at this and I want to look at that, right? And we started setting up a lot of different dashboards and views and charts about all the metrics. But then we realized that that's a lot to ask the level 1 ops team to say, go through all of those, nor all of them meant that there's something critical. So then we restricted that into, we said, okay, we define certain metrics that we care about. We say these are critical dashboards. So these are, if you don't go through anything throughout the day, go those three dashboards, because that means that we need to act on something and we need to take care of it if there's any anomaly. The rest are interesting metrics that we use for capacity planning, we use for trending, we use to see kind of how the environment is doing, but not necessarily something that if I see an anomaly, someone needs to go and jump on that right away. Thank you.
Thanks a lot, Karl. And while we change speakers, Matt, can you raise your hand? We got Matt Saldivar here in the audience from SumoLogic, if anyone has any follow-on questions for him. Tin, you're up next. Where'd you go? And while he gets set up, I'd also like to point out that we're hiring. So if anyone is interested in is coming to work at Yahoo, coming to work on some of the biggest infrastructure around, our recruiter is Jack Tran. He's the recruiter for our production engineering group. You can PM him on the Meetup site, or you can get him at jacktran@yahoo-inc.com. Or you can reach out to me. I'll be happy to forward your request to Jack Tran as well, or go to careers.yahoo.com. So next up we have Tin Lei, who's from LinkedIn. He's going to be talking about how LinkedIn uses the ELK stack. Anyone know a good joke?
Hello? Hi everyone. My name is Tim Lei. I work at LinkedIn.
I hope everyone's awake as I'm the last speaker. I don't have a lot of pretty graphs and stuff, so sorry about that. This is mainly about how we use Elk, Elasticsearch, at LinkedIn, and how we use Kafka as the transport behind it. That we have a lot of logs, so let's get started. There you go. So I used to work for the mobile SRE team, which we're responsible for all of LinkedIn's mobile applications. If you downloaded the mobile app on your Android, your iOS, or your iPad, it talks to the services that we run. And currently it's about 50% of LinkedIn traffic goes to our servers, the mobile servers. I recently transferred to dedicate to Elk at LinkedIn. So the problem we have is that we have lots of data centers, tens of thousands of servers, and enormous amount of logs, right? We have to keep track of them. We have to log them, index them, search them to look for problems. We have to store them. I mean, there's just the demand for doing things with logs to make them useful is enormous. And we have to scale to more data centers. We're building a new one in Asia. And of course, adding more servers. Last time I heard, at the beginning of the year, we were around 40-some thousand. We're a lot more than that now. I'm talking about servers. It's just really hard to manage. We looked into a lot of solutions, commercials, open source. We tried them. I'm sure that you heard of some of these. You might even use some. I think SumoLogic. Somebody heard about that, right? So we tried a lot. Some of the things that we need is they have to be scalable. At our volume, we can't just install it this year and then it fall over next year. It's just not going to do it for us. It has to be horizontally scaled by adding more nodes, not by getting the biggest, fattest servers that you can get. It just doesn't work that way. And of course, the result, when you search log, it has to be fast. I mean, if you get good results, but it takes 24 hours, it's going to be useless, right? By that time, the problem's already much bigger than you like. So, what do we decide on? I think you can guess, right? That's right. We did try some of the commercial solution, and it got very expensive. So we decided on Elk. About 2 years ago, when I joined LinkedIn for the mobile team, we were grabbing through logs. Engineers were logging on SSH onto production servers and run grep. And we have a tool called MSSH, which will do parallel processes across the servers. So when they spin up these MSSH across the hearts of servers, things just doesn't work right. Okay. We had timeouts. We actually brought down services. Well, they brought down services. So we put a stop to that. I put Elk into place for mobile. And as the engineers found out and they started using it, they loved it. And I showed it to other teams at LinkedIn. And they're like, oh, wow, this is awesome. So before I know it, it starts spreading everywhere. Teams start using it, and we start installing all over the place. Okay. So one other thing is log files doesn't scale. You don't want your services writing to log files. There's a lot of reasons why that's not going to scale. So we have log files, or logs goes to Kafka, which is something that was invented at LinkedIn. We use that as a transport, as a temporary storage, and our Elk clusters then consume from Kafka. So that kind of gives us a lot of wins in terms of scaling it, in terms of not requiring a lot of storage for Elk itself, because if an Elk cluster goes down, we can rebuild it from reading again from Kafka, right? Kafka storage currently hosts about 4 days worth on a rotation basis. So we have up to 4 days that we can reread and re-index. Sorry. So ELK, I've been saying that word a lot. ELK is essentially Elasticsearch, Logstash, and Kibana. The three of them together, right? Elasticsearch is the indexing component. Logstash is the component that consumes logs, that transforms it, and then sends it to Elasticsearch. Kibana is the web UI that runs on top, give you really nice WYSIWYG that you can use for analysis of the data that's in Elasticsearch. So Kafka, something we use quite a lot. It's pretty much built into our infrastructure. We use it for as a message queue, as a data bus, as many things. So we have a dedicated SRE team that supports it. This actually was about back in April, early April. So the numbers there are much, much more than that now. We built out a couple more clusters. We expanded the logging clusters. Okay. So we now have a dedicated logging cluster, essentially. It used to be logs goes in the same cluster as some of the other data that we use for business analysis. And we decided that it was safer to have a dedicated cluster for log. And that's done now. Okay. 4 days worth. So that way, again, if we lose an ELK cluster, we can bring it up brand new and just re-index by rereading Kafka again. So, well, at that kind of volume, I mean, some of the issues we run into is bandwidth, of course. Network partitioning, latencies. I mean, all these things are something that everyone, I think, is pretty familiar with, right? There's also security. There are certain servers that cannot share its data and log file with anything else, such as the financial related servers. We also need to worry about data that is transiting between data centers. And of course, it's possible runaway applications. So this is the way that we have our multi-colo data centers. So let me explain a little bit. So every data center has its own dedicated search clusters, ELK clusters, right? That the services send logs to Kafka, and then the cluster consumes from it. When I talked on the previous slide about data concerns, you don't want to spend a lot of money transporting data between data centers. So the clusters that are in each data center consume logs generated by that data center. We don't transport it all over the place. We use what's called the tribe nodes, which is a special client node, Elasticsearch client node, that then aggregates the data. It talks to clusters in all the data centers, and it aggregates the data. That way, the data stays in the data centers, and we use tribe nodes to leverage aggregation capability. Okay. So at a lower level, this is kind of what it looks like. Okay. Kafkas get the log sets consumes from it, sends it up to the data node for indexing. We have dedicated master node that does not do any indexing. All they do is just be masters that talk with all the nodes, we track cluster states. Then we have a dedicated tribe node that runs Kibana on it and that talks to the masters. And it keeps the users happy. So this is, again, pretty familiar with anyone that's in DevOps, right? You have all these different issues: data, transporting it, storing it, ingesting it, indexing it. That's one of the issues that I ran into at first in terms of there was so much log just for the mobile cluster alone, ingesting them fast enough and then indexing them fast enough. So back about in 2013, at that time, Elasticsearch was still, we were running 0.19. They're about ready to release 2.0 now. So there's been a lot of changes since then, a lot of improvement. It's been much, much more stable now. Thank God for that. Yeah, it wasn't fun. Even though I can reindex from Kafka, it takes time, right? You got to rebuild the cluster and then reindex while your user is breathing down on you. It's like, where's my graph? Where's my graph? Sorry, the cluster's down right now. But I haven't run into that recently. Plus, we also have these dedicated clusters, so we can send users to other data centers using the tribe node. So there's another thing too. We have so many clusters now. In the early days, it was fine. I run the mobile out cluster and I help other teams bring up their clusters. But then I have my job to do, right? So we were talking about having a centralized group that owns only Elk. And then we can have that group dole out the resources to the team that needs it. Or we can have each team run their own, but then they can run different versions, right? You can have this team run this version, that one run that version, then we have all kinds of issues in terms of security, patch management, and so on. So we went into a hybrid model, essentially. We have what's called virtual team, run by me. I make sure that the software I imported in from Elastic, we have a central repo. Everyone has to install and deploy from that repo, but they own their cluster. So that ensures that the software is always up to date. And we run scripts regularly to make sure that everyone is running the latest version within that repo. Okay. And then we run the tribe node that gives us aggregated view across all of the clusters. So by default, the tribe node that I run accesses everybody's cluster, except for, there's two clusters I know of that I don't access. One is the security owned one. The other one is the financial. They can't have anybody access their clusters.
Excuse me.
Yes.
On the previous slide, can you go expand a little bit more on the previous slide? Can you expand a little bit more about the auto remediating and kind of?
So we have something that called Nurse that's been in-house by one of our SRE. It's the auto remediation framework, essentially. You can have the software monitors cluster, and you give it all these different parameters. So it monitors based on load, on memory, on disk, and all that. And you tell it what to do when it hits certain threshold. It can restart thing. It can send alerts. I mean, it can do a lot of things. And I have that monitoring some of the clusters. There was a couple of meetups presenting Nurse. I can send it out if you're interested. I think we even have it recorded. Okay. So currently we actually have at least 36 clusters that I know of. A couple of clusters are approaching 40 terabytes. And yeah, they're struggling at the moment. So we're looking at expanding, adding more nodes to them.
Sure.
Actually, I know one cluster where the hourly index is 15 terabytes. It's a challenge. We had problem consuming fast enough to use Logstash, so we ended up writing our own consumer. Just beat Elasticsearch. Logstash just could not keep up. It just killed the CPU. It was CPU bound. Yeah, I know of clusters that have 50. Well, you're not supposed to have that many shards clusters. So, sorry if I'm skipping around a little bit. If you're familiar with Elasticsearch, it's built on top of Lucene, and it does auto sharding. So you have an index, it will automatically shard it. Well, you tell it how many shards you want, and it will shard it across the number of nodes, however many nodes you have, right? And it keeps it balanced. Because it is a Lucene instance, every shard is a Lucene instance. You don't want too many shards, and you don't want the shards too large, because they can really eat up your memory. It's JVM, right? And there's a limitation with the JVM. You don't want to give it more than 32 gig memory. So there's a lot of things. Essentially, you want to scale horizontally, not vertically. What we're doing, we're adding more clusters because more teams are coming online. They want to add theirs. We're actually right now, we're focused on logs, but there are teams now that are sort of using Elasticsearch for other things. There's applications being written on top of Elasticsearch internally. Okay. So this is going to be fun.
When you say horizontal, not vertically, what is your sharding? One class is responsible for one application within a data center?
So ideally, with Elasticsearch, is that you want one shard per node, right? That will keep it evenly balanced. Let's say if I know that I'm going to have, so now I started out with a 5-node cluster, and I know that my daily index is going to be, say, 1 terabyte. Then I might want to start out with 20 shards. That's 4 shards per node with a 5-node. In the future, I'm going to add enough to bring it up to 20 nodes. Now it's 1 shard per node, right? I hope that answers your question.
It's more about the whole cluster Paris data center. You have more clusters than you have data centers. So within those clusters, they then aggregate different kind of log data, so to speak, or
yes.
How they separate that information?
So because each team run their own clusters. When I say team, we have like the mobile team. We have team that say the Post app on LinkedIn, which is the news stream. When you go to LinkedIn website, you get the Post news stream. That's owned by a different team. That team consumes logs from their Post applications. They own their own cluster, right? So that's why there's more cluster and there are more data centers. And because we do not want to transport logs across the data center, so an application is going to be multi-data center. It's going to run across all the data centers. Every data center then will have a cluster dedicated to that application that consumes log for that application. So now, one application, 3 clusters, minimum, right, for 3 data centers, or 4. However many data centers, there's 1 cluster per that application.
But do have teams access to the other teams, the common teams?
So that's what I kind of mentioned about the hybrid. The team own the cluster and they consume only log for their application because they know better the characteristic of the application, how much log they generate. So they can size it appropriately and they can grow it appropriately, right? As opposed to have somebody at central dictate, right?
Do you have a sort of a scaling rule of thumb that says how many gigs per node per day, or?
So we have a standard node size because we buy in bulk, right? Our node is 64 gig of RAM and 2 1 terabyte drives. That's the standard hardware node that we have. Kafka nodes is a little bit different. Kafka node is, so the standard application node is 1U. The Kafka node is a 4U. 16 1 terabyte drive, still 64 gig. Okay. So the issue here is that because it is Java JVM, we recommend everybody use the standard application nodes. It doesn't really make sense to have a lot of storage space and only 64 gig of RAM. The JVM is going to blow up when you have that many indices on that system. It just can't take it. We learned the hard way experience. So I hope that answers. Yes, Brent.
Does each team have its own Kafka topic, or how do you separate each team?
So yeah. it's actually determined by the service, the application that writes to Kafka. They have their own, so it's usually, the convention is service name and then access log or service log, right? But yes, they have their own copy and they consume their copy.
You mentioned about the tribe nodes that are aggregating the data
Yes.
from multiple data centers.
Yes.
Is that aggregating in real time or near real time or only on query?
No, it's real
by
time.
customer?
It's real time.
I'm sorry?
In real time,
Yeah.
because it's just a client node. It talks to all the clusters downstreams in real time.
So it's not querying on demand by the customer?
Well, it is. I mean, so Kibana's running on top of it, and Kibana talks with the tribe node. And during business hours, we got devs and various operation people that goes on and use it. And so the time from when the logs get generated, consumed to it appear is roughly about 9 seconds or less.
I guess my question was not very clear. So my question was whether the tribe node aggregates the data on demand by the customer, or does it pre-aggregate the data?
No, it does not pre-aggregate. It's just a client. It just know how to talk with the downstream clusters.
Thank you.
Right. But it does cache it because it's a Java JVM. Right. Yes.
How have you addressed security with Elasticsearch with regards to not being able to really control who can access Kibana and Elasticsearch, as well as people being able to delete entries out of Elasticsearch?
So yeah, so the Elasticsearch clusters run in production. We have firewall. Only operations have access to it. Dev do not have access, and so the operations are the team who run it and own it. And yeah, they should be able to delete and add whatever they want, but only operations have access to the Elasticsearch node. So in terms of Kibana, which is run on top to give you access, we did our own mod to it to tie it into our LDAP AD.
And does everyone share a common Kibana dashboard, or is it like per user configurations in their Kibana dashboard?
So unfortunately, Kibana 3 doesn't have, well, Kibana 4 doesn't have that either. So we are doing it by convention at the moment. There are shared dashboards, and if users want to make a modification to that dashboard, convention is they make a copy of it with their name in front of it. Right. So that's obvious who owns what. Yes.
Looking forward to Elasticsearch 2, have you considered how you're going to handle the requirements for all the fields in an index to have the same data type?
We haven't looked too closely into that. We're still running at 1.4.5 at the moment. I was going to upgrade to 1.5, then they had a bunch of bugs. Then I was going to do 1.6, they had a bunch of bugs. And then 1.7, they have a bunch. So I'm holding off until they're stable. They're moving so fast that they're kind of not stable. Yeah. Yep.
You mentioned at the beginning cost was an issue. Have you done any analysis of how much it's costing to own your own solution?
So, yeah, we did. We tried the commercial one, so we know how much that costs, right? In this term here, our only cost is the hardware, which is kind of whether we go with commercial or open source, we still have to pay for the hardware, right?
But the people that are managing it all,
it's not that bad. Most of the team is on a part-time basis because they all have their real job, per se, supporting the applications. So they bring it up to help them do the job easier, but they still don't spend anywhere from 10 to maybe 20%. And then once it's set up, it's stable, they kind of ignore it and just let the dev use it, or they use it. So it's most of the time is spent at first bringing it up. Once it's up, it's stable. That's what we found. Yeah.
So are we using the Elasticsearch for the same purpose? writing into the Elasticsearch cluster is pretty fast, like close to real time. But like querying it, especially when you have the query from a tribe node to across all three, the user experience wise is quite challenging, right?
Yeah, it takes some tuning. I mean, right now one of the issues with Elasticsearch is that you can DOS yourself. If somebody sent a query it's kind of like the same with the database. You know, you do select all or something like that on a table that doesn't have the index. You can really kill yourself. Yeah, it's mainly user education. We pre-build dashboard for users and we teach them not to kill the cluster. And we do some tuning too. Like go to use doc values. I turn on doc value everywhere I can, which is pre-built inverted indexes on disk. Right? That saved me a lot of memory space. Yeah.
Touching on the previous comment about price, I definitely find it interesting how the first conversation we were talking about with Yahoo using commercial products, and here you guys are using something you've done in-house, and I'm definitely intrigued on how you guys came to this conclusion that it was less costly to do it in-house, and I'm sure Yahoo came to the conclusion it was less costly to outsource it. I don't know if you can speak to that at all. I'm assuming you guys are similar data size at least, if not Yahoo being bigger, right?
Well, I can't speak for Yahoo.
Yeah.
Lincoln, right? So we've used commercial. We've used a couple very large commercials. Like there was one that charges by amount of data you use, and it becomes very expensive. Before we kill it, it was a couple mil a year. It just wasn't worth it. We looked at it. It's just like we know our data volume is going to go up, and the bill is going to even higher and faster. We're not going to want to do that, right? So we look at it that way, and it's like it's actually less expensive to own our own. Just go ahead and use what's out there. It's well supported, and you know we have the source code. And we actually have been making changes. Yeah. When we first started, I wrote my own Logstash plugin because there wasn't a plugin for Logstash that can consume Kafka, so I ended up writing it myself.
Do you feel it's an apples to apples comparison though between, so like Splunk is probably what we're talking about, right, versus in terms of the value you get, because I understand, yes, it costs less, but the total conversation is what value you get out of it for the organization, right?
It's the 80-20 rule. We got 80% of the usage. We don't have all the nice WYSIWYG and the thing that Splunk offers,
yeah.
But 80% of the functionalities are there. And as a matter of fact, it's been out for 2-3 years now, and the dev haven't really been asking for Splunk anymore. In the early day, they did. They don't do anymore. Our security group, who is a heavy user of Splunk, they love Elasticsearch. They built a ton of dashboards around Elasticsearch. Yeah. They use it daily to monitor, to alert. You know, what can I say?
Cool.
They're one of our biggest users.
And final question, do you plan to buy support at any time from Elastic?
We just did, a couple months ago. So yeah. Yes.
How do you make sure you actually receive all the log files? I mean, with this amount of data, how do you know you're actually getting all of it?
It's good questions, and actually, we are now not getting. We're sampling now. We used to get all of it. Look at the volume, right? So for certain services, we're actually sampling. We're looking at like the one I just mentioned, 15 terabytes per hour. We got a sample. I already told the team. It's like there's no way in hell.
Do you like a pre-filtering on the class, like on the server side? Or when you say sampling, do you just send like periodic, or do you do that?
We're looking at a couple of different. I haven't decided yet which one we're going to use. It may be tied to the particular service in the data. So we haven't decided yet. Some of the other one, like the mobile, we've been sampling for since the beginning because mobile was huge. It was just too much. I started out with a 3-node cluster. That's like what, 500-600 gig of usable space. It's, you know. So we were sampling 10% of the traffic, and actually that was good enough. Yeah.
Are you guys retaining logs forever, or do you have a cron script that's like trimming up?
No, our policy is 14 days.
And you're at 30 terabytes for 14 days?
Yeah.
Rough.
40 terabytes for some of the clusters. Yeah. Yes.
So continuing on that, do you have logs that needs to retain for longer, like for PCI, for example?
Yes. Those are in the special financial cluster. They have their own fund and all that. They have their own resources. So they run their own cluster, and I don't tell them what to do with it. Yeah, it's just their firewall off. I can't get there anyway. So yeah. Okay. Anything else? All right. Yeah, I don't know. Just some extra stuff that how we use our own Kafka plugin to consume, because we're consuming from Kafka, so the Kafka plugin within Logstash is just too slow. Even the one that we released recently by Elastic, it can't keep up. So we ended up using our own, and we can easily consume faster than Elasticsearch can index. So there you go.
Have you published yours?
Yeah.
I have published how to use it. We're actually using KCC, the Kafka Console Consumer. That's open source, it's out there. It can consume much faster than the plugin that Logstash can do.
Thank you.
Yeah.
So are you saying that you're not using Logstash, you actually use the...
We are using Logstash, but only we don't use it to consume we actually use Kafka Console Consumer, KCC, consume, and then use the pipe input plugin. We just shove it in to Logstash as fast as Logstash can do.
And you're just using that as a front end for store and forward because of the large volume that you get in, and it's so burstable, right?
Yeah. Okay. We do some transformation on the data, like dropping things and stuff. And we're going to be using it probably for the sampling that we're looking at. Yeah.
Do you do multi-line?
I think some of the clusters do use multi-line. I don't use it in my clusters, but some of the other guys do.
It's single-threaded, right, with Logstash?
Yeah.
Does that work for you guys?
So I don't use it.
Yeah.
I avoid anything that could slow me down. So, yeah. And actually, we do write some of our own filters just because of these issues. And one of the things, we're looking at Heka, which is a Logstash replacement written in Go.
What's it
It's
called?
really unstable at the moment. So. Yeah. Yeah.
Just curious about the storage, since you mentioned the config of your 1U nodes. Have you somehow automated the deployment of additional nodes in the cluster if they don't hold enough history? Like if it starts bursting, how do you roll those out?
It's very easy with Logstash. I mean, with Elasticsearch, you just add a new node, and you tell it once it joins the cluster, it just automatically balances.
But you're doing that automatically, or
no? We don't do that automatically because the problem we have right now is we don't want the teams to abuse the hardware. we want to justify before they can get hardware. So that's something that has to be done manually. They have to request it to get it approved.
Yeah.
Yes?
You see the next few slides?
It's actually pretty simple. So there it is. So we use the pipe input, right? And we show it out, and that's just a wrapper around the console consumer. And it's actually, it can consume a hell of a lot faster than the Kafka plugin can. So that's pretty much it. I have this online somewhere. SlideShare. If you go to SlideShare and look for my name, you should be able to find it.
So are you using client nodes as your input and then routing, or are you just going
So we run Logstash on the same node as Elasticsearch. So this is the input portion. The output just sends it out to localhost. And then we let Elasticsearch do the routing itself.
So you're running logstash on a data node?
Yep.
Not a client? Okay.
Yep.
Are all the clients, do they have some sort of special Kafka client, or all of your servers, do they have a Kafka client that sends it straight to the Kafka server?
Yeah, so all the application node, most of our service is Java. So it's Log4j. We have a Log4j to Kafka, jar file. That makes it really easy.
What about things like syslog? Are you pushing syslog into all this as well?
So I think, yes, I think so. That's owned by the sysops group. And I think they are pushing it into their own L cluster. They keep a pretty short rotation on the host itself. And they push everything into their own cluster. Yeah. Okay. Anything else?
Yeah, one more on storage. One of your slides said like 40 million documents.
Yeah.
It's about 40 terabytes.
Well, 40 billion actually.
40 billion. Thank you. My math is always terrible. It's zero. It sounds like it's maybe a megabyte per document. I'm wondering, is that?
No, it's actually some depend on the service. Some of the services are actually fairly small, such as the access logs from our ATS access log. That's actually one of the biggest. Our front end are ATS proxies, right? And the access log is enormous. I mean, it's just constant generating. That one's is about 3 terabytes a day. And the record size is roughly about 1.5 to 2K. That's not big, right? It's kind of like Nginx log. Line is pretty small.
Right.
One more. So you said in one of the slides that one of the challenges you had to deal with was actually like applications going rogue, like adding too much log. So I was wondering, like, what did you do to handle it? Like,
kill them. So that's one of the things we're looking at. We're looking at writing a specialized filter for Logstash. It notices when volume, the metric rises too much, and put a clamp on it. So that's something that we're actually writing. We're writing right now to do an auto clamping, so that it will start sampling the minute that the metric rises above a certain rate. But yeah, we had that happen where it just killed the cluster. Yeah.
But sometimes it might just be counterintuitive when something is going off the charts like that. We really want.
Well, we do get alerts for it, right? That something is doing this, but we don't want it to kill it because it affects a lot of other things too. Because it's writing Kafka, and that's why we moved the logging to its own dedicated Kafka cluster. So if that cluster goes down, it doesn't affect anyone else. Right. So that's done. So that way.
So in a general architecture sense, what is your failback plan in case one of these clusters goes offline in one of the data centers? Will you duplicate them? Will you have multiple clusters?
So that's what I mentioned about using Kafka as our backup storage. If the cluster goes down, we just bring up a new one and just reconsume, because Kafka itself holds 4 days worth. Right. So that's our chief backup. It's there, use it. Right. All right, I think that's pretty much it.
Yeah, thanks for coming out, Tim. So one last note before we all go home. We need topics and we need speakers. So if anyone has something you'd like to hear about or something you'd like to talk about, please get in touch with me. I'm on the meetup group. I'm one of the organizers, Ian Flint. Please PM me with any ideas you have about this. Thanks for coming out tonight, and thanks for our speakers.